Hey, congratulations. Boy, the DART team, you really did this one very well. It's been a successful completion of the first part of the world's first planetary defense test. And there were years of hard work. There was a lot of innovation and creativity that went into this mission. And I believe it's going to teach us how one day to protect our own planet from an incoming asteroid. I really look forward to learning all about what's happening from the observatories so they can tell us about the changes in this asteroid's orbit. So thank you to this international team. We are showing that planetary defense is a global endeavor, and it is very possible to save our planet.
The James Webb and Hubble telescopes revealed their first images of a spacecraft deliberately smashing into an asteroid, as astronomers indicated that the impact looks to have been much greater than expected. The world's telescopes turned their gaze towards the space rock Dimorphos earlier this week for a historic test of Earth's ability to defend itself against a potential life-threatening asteroid in the future. Astronomers rejoiced as NASA's double asteroid redirection test DART impactor slammed into its pyramid-sized, rugby ball-shaped target 11 million kilometers from Earth.
Oh, wow. Awaiting visual confirmation. All right.
And we have impact, a triumph for humanity in the name of planetary defense.
Woo. Fantastic.
It was incredible to see how so many years of hard work and creativity resulted in a direct hit of Dimorphos. Was just an adrenaline rush. I'll add that I've been at the lab now for quite a few years, and I've been involved in a lot of missions and achievements, and never before have I been so excited to see a signal go away and an image to stop.
Final image was taken just 1 minute before impact, 6 kilometers above the surface of Dimorphos. Images taken by Earthbound telescopes showed a vast cloud of dust expanding out of Dimorphos and its big brother Didymos, which it orbits after the spaceship hit. While those images showed matter spraying out over thousands of kilometers, the James Webb and Hubble images zoom in much closer, said Alan Fitzsimmons, an astronomer at Queen's University Belfast involved in observations with the Atlas project. An image taken by James Webb's near-infrared camera, NIRCam, 4 hours after impact shows plumes of material appearing as wisps streaming away from the center of where the impact took place, according to a joint statement from the European Space Agency. Hubble images from 22 minutes, 5 hours and 8 hours after impact show the expanding spray of matter from where DART hit. Ian Carnelli of the European Space Agency said that the really impressive Webb and Hubble images were remarkably similar to those taken by the toaster-sized satellite LICIA Cube, which was just 50 kilometers from the asteroid after separating from the DART spacecraft a few weeks ago. The images depict an impact that looks a lot bigger than we expected, said Carnelli, the manager of the ESA's Hera mission, which intends to inspect the damage in 4 years. The Hera mission, which is scheduled to launch in October 2024 and arrive at the asteroid in 2026, had expected to survey a crater around 10 meters, 33 feet, in diameter.
The deflection by DART will be measurable from ground with telescopes. However, only with Hera coming up close and inspecting the asteroid will unveil all of those parameters that will allow us to plan for a deflection mission if one day we need one. This is the propulsion module of the Hera spacecraft that will take us to asteroid Dimorphos and will allow us to study the results of the DART impact. The propulsion module is being built here in Italy and then will be sent to Germany, where will be mated with the instruments and the rest of the spacecraft to be ready for launch in October 2024.
It now looks like it will be far bigger, Carnelli said. If there is a crater at all, maybe a piece of Dimorphos was just chunked off. The true measure of DART's success will be exactly how much it diverted the asteroid's trajectory, so the world can start preparing to defend itself against bigger asteroids that could head our way in the future. It will likely take Earthbound telescopes and radars at least a week for a first estimate of how much the asteroid's orbit has been altered, and 3 or 4 weeks before there is a precise measurement, Carnelli said. If you like the information, do follow for more and stay curious.